I'm going to talk today about management and control of wax and stickies. Part 1, we will cover various methods used for measuring the concentration of stickies, and part 2, we will talk about the control of stickies. Whenever you want to control anything, you need to be able to measure it. So we'll talk about various methods used for measuring the concentration of stickies. Before we talk about various methods to measure the concentration, let's look at what are adhesives, how do they work, and what are their properties. Adhesives have been developed so that they have to be able to wet the substrate, and subsequently it may absorb and form weak or strong bond with the substrate, followed by the diffusion of adhesive within the substrate. Various sources of stickies include both natural from wood and the synthetic used in the converting operations and the used by consumers. For example, in the wood, we are talking about pitch material, fatty acid, rosin acids, and esteric material. Synthetic stickies include adhesives like the pressure sensitive adhesives and hot melts that are used widely in book binding, and the binders that are used in inks and coatings. Two primary adhesives are hot melts and pressure sensitive adhesives. Hot melts consist primarily of vinyl acetate polymer or related material, and they use some kind of tackifier like rosin to allow the hot melt to wet the substrate, and then they use varying proportion of wax to adjust the melting point of hot melt. Most of the hot melts are 100% solid at room temperature, but they soften around 150 to 250 degree Fahrenheit depending on the composition and specifically the amount of wax. Most of the hot melts are insoluble in aqueous media under any pH conditions, but they dissolve readily in many organic solvents like dichloromethane, trichloroethane, perchloroethylene, chloroform, and so on. The density of hot melt could vary between 0.9 and 1 gram per cc. Pressure sensitive adhesives are composed of rubbery elastomer as a primary component, for example styrene butadiene. They also contain some tackifier to allow the adhesive to wet the surface, and then there are some inorganic oxide used as the fillers. Like hot melt, pressure sensitive adhesives are also insoluble in aqueous media but dissolve readily in many organic solvents. Due to the presence of inorganic oxides, the density of some of the pressure sensitive adhesives can be slightly above 1. Some of the problems caused by stickies include the effect on paper machine runnability or product quality. Stickies deposit on paper machine wire, felts, dryer surface, and cause all kinds of problem in paper formation or drying. Stickies also affect product quality as the appearance of the sheet will be affected. It could give a lot of problem during the printing and converting operations, and also it can give you problems due to holes in the sheet. In short, stickies cause lot of problem in terms of paper machine productivity and the final product performance. We can classify stickies roughly into two groups. Primary stickies are those that are present in the existing environment, and secondary stickies those which appear due to change in environment, such as pH, temperature, or other wet end chemicals. We will be talking mostly about the primary stickies. Secondary stickies are something you have to be concerned about when they appear, and accordingly adjust the environmental conditions so that they don't give as much problem. When we talk about primary stickies, we are talking about either macro stickies, which are large in size and correspondingly retained on 6-cut slotted screen. Those that pass through 6-cut slotted screen are called micro stickies. And here I have said that 0.15 millimeter or 6-cut slotted screens are used to identify or distinguish between macro stickies and micro stickies. Some people have used somewhat smaller slot size, for example 0.01 inch or 0.075 inch and so on. So we don't have any standard procedure for selecting the size of the slots, but most common is the 6-cut, and some people use 4-cut or 3-cut. Why do we want to classify stickies into macro stickies and micro stickies? The main reason is that there are different methods for measuring the concentration of macro stickies and micro stickies, and more importantly, there are different strategies for combating the problems caused by macro stickies versus micro stickies. For example, if you have too many macro stickies, that means the problem lies in the screening and cleaning system. As opposed to if you have too many micro stickies, the problem lies not with the screening and cleaning system, because most of these micro stickies will pass through the existing screens, cleaners, and other equipment. So these micro stickies cannot be removed by the existing technology, except some micro stickies can be removed by dispersed air flotation or the froth flotation, and also via dissolved air flotation. But in general, the removal efficiency of micro stickies is relatively small, and they pass through the system and end up in the paper machine system. So for these micro stickies, you need some kind of additives to pacify them. And these additives are used to stabilize the micro stickies so that they don't agglomerate and cause associated problems. There are many methods used for measuring the concentration of macro stickies, and we'll just go through some of the methods to give you the flavor of how different people use different approaches to measure the concentration of macro stickies. So, Institute of Paper Chemistry in Appleton, while it was in Appleton, developed the fluorescent speck counting method. Some equipment suppliers, Sulzer as Jervis, developed their own method so that they can guarantee the performance of their equipment. Southeast Paper Mill in Dublin, Georgia, had a lot of complaint about the stickies in their newsprint. So they wanted to upgrade their de-inking system and wanted to install the fine slotted screens. And so they developed a method which we call Southeast Paper method to evaluate the performance of various screens. And then there is a so-called various die methods. So just going through some of these methods briefly. In the fluorescent speck counting method, for example, we take a 100-gram stock sample and process it through 6-cut slotted screen. We take the rejects and collect it on a filter paper, blend it with clean virgin fibers, and correspondingly make hand seats. We sandwich this hand seat between the clean filter papers, hot press it between 300 and 350 degree Fahrenheit, allow to cool it under pressure, and eventually you separate the filter paper from hand seats and examine the filter paper under the UV light, and we see those blue specks, and we count the number and area of these blue specks to identify the stickies in the sample. Sulzer-Escher-Wyss method involves again the same step, going through 100-gram stock screening process, and we collect the screen rejects on a filter paper. We place this filter paper on a black board and dry it at 200 degree Fahrenheit and hot press it at 265 degree Fahrenheit. We brush off the usually held fibers, but what happens is that stickies will pick up the fibers from the filter paper and will appear white, and we count these white specks on a blackboard by going through image analysis or by manual means. Southeast paper method, on the other hand, involves manual counting and examining of stickies. So they go through the same process of taking 100-gram stock, processing it through 6 slotted screen, take the rejects, blend it with clean fibers, and make hand seats. Now they take this hand seat and examine under microscope using the probe to identify and distinguish stickies from non-sticky material, and they count and measure or estimate the area of these specks. This is the manual method, relatively tedious but supposedly very specific to the amount of stickies. The so-called dye method use the water-soluble black dye, which will be picked up by the cellulose fibers but not the stickies, and that way you can distinguish between the stickies and the background. Or you can use the hydrophobic blue dye that will be picked up by stickies but not by the cellulose fibers, and correspondingly you will have blue specks in a white background that you can count by using image analysis. Recently there are many more methods developed for measuring the concentration of macro stickies. Some of them are so-called Ingidi method, the pickup method, solvent extraction method, enzyme method, Pullmack method, and wet hand seat method. We won't be going through all of this, but some of the important ones, let's just kind of go through that little bit. The Ingidi method is available on the website. Ingidi, by the way, is a research organization of various European de-inking mills, and they got together and developed this method for measuring the concentration of macro stickies. This method involves many steps, starting with the taking the stock sample and going through the screening process, collecting the rejects on a white filter paper, and then we cover the filter paper with silicone coated release paper and dry it, remove the silicone coated paper, and subsequently we dye the filter paper with black dye and dry it, remove the silicone coated paper, dust it with alumina powder that will be picked up by stickies, and subsequently you count the white specks on a black background. That is the Ingidi method. And the purpose of the black dye and the alumina powder is to distinguish between the non-sticky ink particles and the black sticky particle, because both the ink particles and stickies are black. And so when you sprinkle with the aluminum powder only stickies will adhere to the alumina powder, but not the ink particle, which are non-sticky. And that is why you go through this detailed procedure. The next method is the so-called pickup method, which is developed by Voigt in Germany, and it's currently called the Tapi test method T277 provisional method. In this method, again you go through the screening process but collect the rejects on a black filter paper. And this filter paper is subsequently covered with a special coated paper, and you hot press it at high temperature and pressure. Subsequently, you remove the coated paper, and the coating material will be picked up by the stickies. Excess coating is washed off, and white specks are measured on a black background using image analysis. Some people try to use solvent extraction method. As I said earlier, many stickies dissolve in solvents like dichloromethane and trichloroethylene and so on. So you can use the solvents to dissolve out the stickies and get an estimate of how much stickies are there in a given sample. Another method involves enzyme method, whereby you convert the cellulose fibers into glucose using the cellulase enzyme, and subsequently go through the screening process to count the macro stickies and micro stickies. Pullmack laminator method involves collecting the stickies on a filter paper and putting a overhead transparency plastic film over this filter paper and pass it through a laminator, so that stickies under pressure and temperature will transfer from the filter paper onto transparency film, and you can count the area and the number of stickies by image analysis. The last item is the wet handset method, which seems to be very useful, particularly in the brown grades. And the idea here is that when you wet a handset, it becomes translucent except where there are hydrophobic particles. So when you wet it, you can see the hydrophobic particles, and those can be counted by using image analysis again. Micro stickies are defined as those that pass through 6-cut slotted screen or 4-cut slotted screen. So these are the small sized stickies. We have to recognize that there is no lower limit for the micro stickies. And secondly, that there are some stickies which may be larger than 100 micron but could pass through the slotted screen because they are relatively thin and flat shaped. Nevertheless, it gives you some idea of the stickies that pass through the slotted screen. Micro stickies quantification method involve depositing these stickies on a hydrophobic medium like low density polyethylene film in the case of Berol method, or on a plastic bottle in the case of Buckman method, or on a polypropylene packing material called microfoam by the Doshi method. And lastly, it can be deposited on a paper machine wire using the so-called Pyra method. Paprika in Canada has developed a method where they use high consistency pulp in a Hobart mixer and put the plastic plate on the mixer blade and deposit the stickies on this plastic plate. Just giving you the flavor of some of the methods again, we take 10 gram of fiber at 2% consistency, and you heat it up to 150 degree Fahrenheit, add pre-weighed pieces of low density polyethylene film, mix it for 1 hour, remove the film and rinse it in cold water to remove the loosely held fines and filler material, and fix the stickies on the plastic film. Correspondingly, you dry and weigh the film, and increase in the weight of the film is related to the amount of stickies in the pulp. Now, if you want to test different chemical additives to see how effective they are in pacifying stickies, we repeat essentially the same process, but before adding plastic pieces, we add this additive or the chemical that is supposed to pacify the stickies. Mix the chemical or the additive for about 10-15 minutes. Now you add the plastic film and carry out the process. Increase in weight is now much less compared to before without the chemical. That means this chemical is effective in reducing the amount of deposits on the paper machine. Microfoam method follow essentially the same steps, except now you add microfoam, which is the polypropylene packing material. So various methods for measuring the concentration of microstickies include the deposition test that we just described using hydrophobic media such as polystyrene wire used in paper machine, low density polyethylene film, high density polyethylene bottle, and polypropylene microfoam. In addition to that, people have used solvent extraction method. Institute of Paper Science and Technology has developed a method that is based on measuring total organic carbon. Then we have the so-called PMV method, which is similar to the Ingidi method. And then in Spain, the people at the university has developed a method using the special equipment and depositing the stickies on a stainless steel plate. Thermogravimetric method is not that widely used. There is a TAPI method developed by Robert de Jong, and then there are a few other methods. As I said before, microstickies have not been distinguished in terms of the lower size or the smaller size. So we need to classify microstickies further based on the size as suspended stickies between 20 and 100 micron, dispersed stickies between 1 and 25, colloidal stickies, and the so-called dissolved stickies. Just to go through the classification here, we have a scale from 0.01 micrometer on the left, and logarithmic scale going up to 1000 micrometer. And those stickies which are larger than 100 micron are classified as macro stickies. Suspended stickies mostly deposit on hydrophobic media, and they are classified in the range of about 20 to 110, 120 micron. Then you have dispersed stickies in between 1 micron to about 20 micron. The colloidal stickies are those which are smaller than 5 micron. Those which are dissolved stickies or macromolecules that could give you some problem later on are usually smaller than 0.01 micron. And these are all suspended, dispersed, colloidal, dissolved stickies are classified as micro stickies. The reason for this classification of micro stickies is that different methods used for measuring the concentration of microstickies fall into different regime of the microstickies. For example, solvent extraction method, where we dissolve the stickies from the whole pulp and from the screened pulp, and from the difference in the extractable material, we calculate the amount of microstickies. So the difference in the weight of the extractable material is used to calculate the amount of microstickies by solvent extraction. So solvent extraction method essentially measures all the stickies from 110, 120 micron all the way up to the very small size. The method developed at the Institute of Paper Science and Technology using total organic carbon method. In this case, we take the sample of the water, for example, and filter it through 25 micron Wattman filter and measure total organic carbon in the filtrate. And you take this filtrate and go through 5000 molecular weight cutoff ultrafiltration membrane and measure the total organic carbon in the permeate. The difference between the two is classified as related to micro stickies. So here is a graphic picture of how we measure the micro stickies by the IPST method using total organic carbon. We basically go through the filtration process using 25 micron filter, measure total organic carbon, and filter it again through 5000 molecular weight cutoff ultrafiltration membrane and measure the total organic carbon. And the difference between these two measurements is assumed to be related to the amount of microstickies in the sample. So this method essentially goes from 25 micron all the way down to dissolved material. So the slight difference between the amount of stickies considered by solvent extraction method and those considered by the IPST method. The people in Germany developed the rotating wire method, where here is a wheel on which a paper machine wire is mounted, and the wheel is rotating in the suspension of the pulp, which has a micro stickies in it, and micro stickies will deposit on this wire, and subsequently you measure the amount of deposits on the wire, and those are the micro stickies. Venditti and associates at North Carolina State University used the barrel method to determine the amount of microstickies deposited on polyethylene film. So in this case, you take 4 different beakers, put your pulp sample in each of the beakers, and heat it up to about 165 degree Fahrenheit or thereabout, and put in pre-weighed pieces of plastic film. For half an hour you stir it, let the microstickies deposit on the plastic film, and then you take out the plastic film, rinse it with cold water, and measure the increase in weight of the plastic film. And we won't go through the PMV method, but basically all this deposition method measure the microstickies within the concentration range of about slightly about 10 micron to all the way up to 120 micron, 200 micron, whatever. We don't know the precise range, but they are somewhere in the suspended stickies range. So here we see 3 different methods: deposition method, IPST method, and solvent extraction method, covering different regime of microstickies concentration. And we won't go into the thermogravimetric or UCM method, but they again cover different regime of the microstickies. Lastly, very recently, researchers at Paprikon in Canada developed a method where they filter the stock through bridge jar using 100 mesh screen, and take that filtrate, put it in a bridge jar, another bridge jar where you have mounted a forming wire or a paper machine wire right here, and subsequently filtrate that comes out from this bridge jar is pumped back into the bridge jar, and this process of recirculation is continued. Eventually more and more stickies will deposit on the forming wire, and you will need higher pressure drop for the same flow of filtrate through the bridge jar. And so in this method, using the computer, we measure the pressure drop as a function of time through this forming wire while having the same volumetric flow through the system. Here is a picture of the setup. This paper was presented or published in the May 2004, and here we see example of how the pressure drop varies with time as more and more stickies are deposited on the wire. And the slope of this curve or straight line is related to the amount of stickies depositing on the wire. So in short, there are many methods used for measuring the concentration of macro stickies and micro stickies. Depending on the specific application in research or the mill or the process control, you want to modify one of these different methods to evaluate the concentration of macro stickies or micro stickies. Now we'll go through several strategies to control the stickies. Here is a list. Excuse me for a second. So several strategies for combating the problems caused by stickies include proper selection of the recovered paper, gentle pulping and deflaking, proper design of screening and cleaning system, effective water clarification, dispersion and kneading if needed, and finally additives to stabilize micro stickies. We have to have some control over the recovered paper quality. So the first question that arises is, what do we mean by quality? What parameters we need to measure, and what is the sample size and how big a sample to take, and so on. So as far as we are concerned in this particular chapter, we will talk about stickies as the main criteria to qualify recovered paper. So we want to measure the amount of stickies coming in with the recovered paper. So what you want to do is to grade different recovered paper suppliers to see what amount of stickies are coming through different grades, and accordingly identify the supplier bringing in the greatest amount of stickies, and accordingly you can get a greater control of the quality of recovered paper. The second strategy in combating the problem caused by stickies is pulping and deflaking. So here we want to do relatively gentle pulping at high consistency, preferably using drum pulper or high consistency helical rotor pulper, because they degrade the stickies to the least extent. And subsequently large size stickies can be removed by the use of screens and cleaners. The third item is the screening and cleaning, and here we are using coarse screen with holes and fine screen with slots, followed by cleaning, that is the use of forward cleaner, reverse cleaners, and or through flow cleaners or gyro cleaners to remove the contaminants with density greater than that of water or less than that of water. Water clarification is very effective in removing micro stickies and should be used. Dispersion and kneading, they do not remove the stickies, but they break down the stickies so that they are not visible, and sometimes fix it to the fiber so that they don't create any problem. In very specific cases, you might be able to even agglomerate the stickies so that you can subsequently remove it by the use of screens. In general, proper following of these strategies will take care of macro stickies problem. Micro stickies, however, cannot be removed by this existing equipment. Some of them could be removed by the use of flotation, but most cannot be, and therefore you need additives to stabilize the micro stickies. Various kinds of additives are available in the market: inorganic, talc, and zirconium compounds, and organic, which are widely used, cationic, to spray on the paper machine wire, for example, to reduce the deposition of stickies, and ionic polymers are used to impart strong negative charge to the micro stickies so that they will repel each other and won't agglomerate. Non-ionic surfactant type material is used to make micro stickies somewhat hydrophilic and prevent the agglomeration, and so on. So there are many types of organic additives are available to stabilize and pacify micro stickies. So in general, strategies for macro stickies include proper screening and cleaning after gentle pulping and proper selection of the raw material. And strategies for micro stickies include, of course, gentle pulping, effective water clarification, and finally additives to stabilize the stickies, and proper selection of the wet and chemicals so that they don't end up agglomerating micro stickies. We won't go through some of these processes because they are really not used in handling stickies. But one possible approach to the stickies problem is to modify the formulation of the adhesive so that they don't create too much problem when you recycle the paper. And in general, we do not like water soluble adhesives or water dispersible adhesives, but we would prefer the adhesives that could be removed by the use of existing screens and cleaners. And with the help of United States Postal Service, we have been able to screen various adhesives and come up with few that could be effectively removed by the use of existing screen and cleaners. That's it for the management and control of wax and stickies. Thank you.